Okay, so in this video we're going to cover section 2.3, which discusses modeling with differential equations. And the typical problems that we're going to discuss are mixing problems, compounded interest, population dynamics, which we're going to leave till next section, and falling objects. So here's our first example, and it's a mixing problem. So here, the Fluid Labs runs hydrodynamic experiments. And you can imagine that after one experiment, a tank has 200 liters of a dye solution with a concentration of 1 gram per liter, okay, of the particular dye. And if you're an undergraduate student who wants to clean the tank, you're doing it by adding fresh water at a rate of 2 liters per minute. And then you're uniformly searing the solution, and finally draining at a rate of 3 liters per minute. So the question is, how long is it going to take you to clean the tank so that only 10% of the original amount is left inside? Okay, so the first thing that you need to do is to determine what the quantity of interest is. And here it's going to be the amount of dye, which I'm going to denote by x of t. And we also need to know what the total volume is at a particular time t. And I'm going to denote that by v of t. So here is the graph sort of illustrating what's going on. We have this tank, which originally at time t is equal to 0 has 200 grams of the dye because the concentration is 1 gram per liter, right? You have fresh water flowing in, and that's 2 liters per minute, that's the rate. And you have 3 liters per minute of the concentration flowing out after it's been sort of uniformly mixed. And so really you expect that in those 3 liters you have the amount of dye x of t divided by the volume coming out. So we first need to know what the volume is here, right? So what is the volume? Is the first question that we want to answer. Okay, and you can see that the equation for the volume actually is dv dt is equal to 1. Why is this? Is because, again, if you think of this as flow in minus flow out, we know that what was flowing in was 2 liters per minute, and what was flowing out was 3 liters per minute. So if I drop the units, I end up with just minus 1, right? And so we can actually solve this, right? We have dv dt is equal to minus 1. And I know that the initial condition, remember, was 200. The initial volume was 200. This can be easily solved, and we get that the solution is 200 minus t, right? You can easily check by taking the derivative. So we have found out what what the volume is. Okay, so our final model is dx dt is minus 3x divided by 200 minus t, because that was the volume. That's how the volume is changing. And the initial condition was 200 grams, right? Now this is a linear equation, which we know how to solve, so let's solve the ODE. And we can do that by rewriting this as 1 over x, moving x to the other side, and then we're left with minus 3 over 200 minus t. Okay, and this can be rewritten as the time derivative of the natural log of x, and this remains the same, Okay, and so now we can integrate, and we get natural log of x of t is equal to, the antiderivative of this is going to be 3 natural log of 200 minus t. And the negative here cancels out because of the chain rule here from that minus t, plus a constant. And so we can exponentiate both sides and get e to the natural log of 200 minus t cubed plus a constant, which we know is just a constant, not e, but rather 200 minus t cubed, because the constants allowed to be positive or negative, we can get rid of the natural log sign. And so we have solved it. We just need to substitute in what the initial condition is. X of 0 is constant times 200 minus 0. So that's just going to be 200 cubed. That's just constant times 8 times 10 to the 6th. Okay, that's equal to 200, so that gives me that c is 1 over 4 times 10 to the 4th. And my final solution then is of this form. So now we can answer the question, which was when is it the final amount going to be 10% of the original amount? So we're looking for x of t is equal to 20. And so we can just figure out what x of t, which is 1 over 4 times 10 to the 4th, 200 minus t cubed is equal to 20. And some algebra just gives that t is equal to approximately 107.17, something like that. Okay, so this is the answer.